Chapter 15, Urinary Renal System, Screencast 3. Now, this screencast is going to focus on the actual formation of urine, and there's three processes that are involved in the formation of urine. The first is glomerular filtration, the second is tubular reabsorption, and the third is tubular secretion. So let's take a look. And here, this nest or knot is the glomerulus. So this is the site of filtration. So water, ions, glucose, amino acids, bicarbonate, waste products, they're all filtered from the glomerular capillaries into the space within the glomerular capsule. So it's going to go that way. Then we have tubular reabsorption. So this is going to involve going from the tubule back into the bloodstream. So once again, leaving the tubule, going into the bloodstream. Now, during tubular reabsorption, water, amino acids, glucose, most ions, and some urea are reabsorbed back into the peritubular capillaries. This primarily happens in the proximal nephron. The third process is tubular secretion. Now, secretion is going to involve the movement from the blood into the tubule. Okay, so you want to make sure that you're comfortable with the various definitions of these three terms. Some drugs, waste products, ions, what they're going to be doing is actually being secreted from the peritubular capillaries now into the distal tubule. So that's where that's taking place. So remember, typically tubular reabsorption is taking place in the proximal tubule, whereas tubular secretion is taking place primarily in the distal tubule. Now, what filtration involves is driven by a hydrostatic pressure, and what it's doing, it's actually filtering protein-free plasma from the capillaries into the glomerular capsule. Now, the glomerulus has slits bigger than other capillaries, so this is where it actually acts as a very selective filter based on size. So large proteins and things as big as cells are not going to be able to be filtered, so they will stay within the glomerulus. Now, the rate of filtration is regulated two different ways. At rest, it's under local controls that adjust the diameter of the afferent arterioles. And remember, that's how you actually get into the glomerulus. Stress will actually cause sympathetic nervous system to reduce blood flow to the kidneys. So those are the two primary mechanisms in which the rate of filtration is actually regulated. Here you can actually see a little bit more clearly that nest of capillaries, and you can actually see slits. Okay, so it's much more porous than other capillaries. And then so the filtrate is now going to leave and enter the proximal tubule. Now, as noted previously, the proximal tubule is where most reabsorption is taking place. Now, there's one thing that I want to point out on this particular diagram, or table, excuse me. I want you to take a look at potassium and urea. They are the only two molecules or substances that are not reabsorbed at 99% or above. So potassium is reabsorbed at 93, urea is reabsorbed at about 50%. I want you to be comfortable with these two things. Okay, so that's important. Now, as I said previously, 100% of filtered glucose, amino acids, and bicarbonate, and 50% of urea are reabsorbed within the proximal tubule. 65 to 70% occurs in the proximal tubule, 25% occurs in the loop of Henle, less than 10% reabsorption is taking place in the distal tubule. The brush border of the microvilli in the proximal tubule cells really facilitate reabsorption, and that's an adaptation that is going to define what the proximal tubule actually does. And we can see this here. We can see all of the microvilli. Okay, and once again, this is the proximal tubule, and it's designed primarily for reabsorption. Now, Sodium will be moved by active transport out of the tubule cell into the interstitial fluid. But let's take a look at these diagrams, okay? I'm not going to want you to get into the real significant detail of the process here. There are some things that I want to point out. Glucose in the non-diabetic is actually going to be reabsorbed at 100%. Now, one thing I want to point out, if you're a diabetic, they're classified as individuals with higher than normal blood glucose. So the high blood glucose levels are going to overwhelm the glucose transporters that are responsible for moving glucose out of the tubule. So that glucose actually ends up in the urine and it'll be excreted. Okay, so just wanted to point that out. And once again, we're looking at these other mechanisms, okay? And once again, I'm not going to go into a lot of detail. They consist of active transport and diffusion, but don't get concerned about what is moving how. The most important thing I want you to see here is the tie-in between high glucose levels and the diabetic. Now, secretion is going to be moving in the other direction. So substances from the peritubular capillaries are going to be moving into the tubule. Now, here, you're basically regulating chemicals in the body. Okay? And so you're also looking at the excretion of harmful chemicals. So substances that are secreted into the tubule are going to be drugs such as penicillin, cocaine, marijuana, pesticides, preservatives, hydrogen ions, ammonium, potassium. So all of that is going to be secreted into the tubule, and it's going to become part of the urine. Now, remember, when someone's going in for a drug test, they're not giving a blood sample. They're actually giving a urine sample, and that's because of what is excreted into the urine. The metabolites of many drugs and all of those other toxins, etc., are going to be incorporated into the urine. So that's why that's used when someone is being drug tested.